Hey guys, Buildzoid here, and today we're going to be taking a look at this thing. It should be pretty obvious that this is a GTX 1080 Ti. There's only really one thing you can conclude from that. This is the 1080 Ti that I got sent because it blew up. Well, and it didn't blow up because of a hardware malfunction. Basically, the guy who sent this to me, he had it was in a water loop and the loop leaked, and then after reassembling the system without really waiting long enough for everything to dry properly, the PCIe slot basically burnt out on the card, and he sent the card to me for repair. So yeah, I repaired it, and I've also heavily modified it, as you can clearly see at this point. This is just the front of it. Like, there's more on the back, right? And yeah, so this is, and it's not quite finished yet. So there's a couple more things I want to do. I want to add a temperature probe. I want to add and it needs to get plasti dipped because I do intend to run this on liquid nitrogen. So yeah, it's really unfortunate that I'm about to run a 1080 Ti right as the 2080 and the 2080 Ti are about to come out, so it's like all of my high scores are going to be irrelevant within like a week. But whatever, you know, just how it goes for me. You know, I'm never on time to the party. I'm always last. Anyway, so yeah, I guess let's start with like the basic things that were necessary to get the card running, and then expand into the things like the actual modifications. So first of all, blown up PCIe slot. Basically, I just cut off the blown up part, disconnected the 12-volt power plane. So you can see there was a shunt over here. That shunt is okay. Actually, this is why I have the second camera. I can give you close-ups. So we're gonna put secondary camera here, and come on, go. Up. So right there would have been a shunt. That's not there because on the other side of like this side is still shorted to ground. So that part's still shorted to ground, so I had to remove the shunt because that short is somewhere in this area, and I have no idea how to find it. And basically I cut off those pins anyway, so it's not like the card's going to get power from there. So yeah, so shunt got removed to basically isolate the short circuit. Then we have this 18 gauge bodge wire going from this shunt up here down to there to deliver 12 volts. Now, I didn't feel like that was robust enough, so over here I actually found that you can see these 0 ohm resistors. So these are actually designed for allowing the engineers at NVIDIA to basically rebalance the power distribution through the card after it's been produced. So these 0 ohm ones right here, that's stock, but this nasty blob right there, that connects the power plane that originally was running off of the PCIe slot to the 8-pin power plane, I think. Yeah, it's connecting the 8-pin one. So yeah, that's what that blob right there is for. Basically, it takes some load off of the yellow wire. So that's that. Since we're already on this side of the card, I guess we're just going to go around. Blue line is voltage measurement for the PEX rail. Originally I thought I was going to volt mod that, and then I decided I am way, like, this thing, like, takes way too long, and I've had it, and I'm not bothering. I have memory and vCore modified, and I'm just not bothering with the PEX rail. It's just not, like, I don't care. If it costs me 50 megahertz at this point, I don't care. I might maybe do it afterwards, but right now, not particularly interested in doing that. This horrible octopus thing right here, that's how I took care of the fact that, hey, the shunt's literally not there. So obviously that would massively trigger NVIDIA's power monitoring system. So I basically completely rewired the entire power monitoring system. So right now, basically what's happening is I think this is a 120K and a 33 ohm resistor in series, basically set up to be a voltage divider from 12 volts to ground, and the voltage on that should be like 11.997 volts or something like that, and that's basically fed into the current monitoring chip, which is plasti dipped into place because I really screwed up that area because it's not very accessible. So yeah, I took off way more SMDs than I actually wanted to. And there's like a few traces there which are basically on the edge of being ripped out. So had to plasti dip the entire area just to make sure that it doesn't disintegrate. And now the card basically thinks that it's pulling 16% of its rated TDP all the time, which is great, because it can't power throttle. You know, at full load, we're pulling 16%. At idle, we're pulling 16%. Because that is, like, it's feeding it a complete lie about how much power it's pulling. And this is a high enough power draw that the... Like, if you do a shunt mod where you just shorted over the shunt with, like, a blob of solder or something... what happens is actually the NVIDIA driver realizes that like the reported power consumption is way too damn low and doesn't let the card run anymore. So that's what's going on over there. This switch, we're going to have to flip the card over for. Here we have some more modifications. So that switch is for 600 kilohertz VRM switching frequency. Basically, send VRM efficiency to hell. It also slightly helps with core clock stability, which actually really surprised me because this card really doesn't, like, clock very high. But at 600 kilohertz, it got all the way through GT1 and then crashed on GT2 at, well, at like 7 megahertz more than if I didn't have that switch. It does send VRM efficiency all the way to hell, though. So... that's what that is. Then this red wire, that's for VREF, so there's 2 volts on that. That goes to a potentiometer. This white wire is for ref in. So this is basically soldered on right there. And that basically, the voltage on this wire tells this chip right here, which is the UP9511, what voltage the vCore VRM is supposed to spit out. So... that's how we get voltage control. On the end of that is this, and that's just a voltage divider between the ref in, VREF, and ground. VREF is 2 volts, ref in is the voltage that we're actually controlling, and ground is ground. There's a switch there to cut the voltage, drop the voltage down. Unfortunately, some idiot wired it wrong, that idiot being me. So instead of, like, originally what this is supposed to do is just, like, that switch normally is supposed to be wired to disable the mod. But because, like, if I was working on a different kind of voltage controller, the way this is wired is actually correct. But because I'm working on what I'm working here, it's not correct. So it does drop the voltage, it doesn't disable the volt mod. Because if I disable the mod, the card should be sitting at, like, 0.6 volts. Whereas right now, it's basically, like, minus 10%, or roughly something like that. So it does still give you a nice voltage drop if you need it, but it's not, like, a proper disable right there. And that's a 1000 ohm potentiometer, and I use 1000 ohm potentiometers because they're so low value that you can override everything with them. It's also limited with a 330 ohm resistor up towards voltage, and a 680 ohm resistor towards ground. So minimum voltage should be around 680 millivolts or thereabouts, 700 maybe. I'm not sure. I don't particularly care exactly where it's going to stop. And then maximum voltage should be around 1.7 volts. So yeah, that's how that's wired up. Right, the 600 kilohertz mode is basically, that's a 27K and a 33.9K in series, as you can clearly see, and they're just pulling program pin 6, which is... I don't remember which pin that is on the UP9011, but prog 6 is basically getting pulled to, like, that goes to ground and to prog 6. And the stock resistance is 33 kilo ohms, which translates to about 300 kilohertz switching frequency. With this, in parallel with that, it pulls it down to little over 15, like right around 15.9 K ohms, and 16 K ohms is 600 kilohertz. So I'm a little bit off, but, you know, it does work. So it runs 600 kilohertz. These are the limiting resistors for the vCore mod. So that's the 680 limit, and that's the 330. So that limits how much voltage you can, like, that stops you from going all the way to 2 volts, basically. That's what that's for. What else is there? Right, so that's that. Right, white wire running all the way across the card, and through this screw hole right here, we flip the card over. And that goes to here, which this right here is a 1.8 volts regulator, and that's a 6.6K ohm resistor. And the reason why that's there is because I wanted to override the phase control. So normally this VRM will disable its phases when you're going into idle, because it's a 7-phase, and so it'll drop some of the phases when idling. What I have here is it'll never drop phases, ever. It just runs all phases all the time, which is really inefficient, but it can help with overclocking performance, because basically you have less ripple and more phases more better. Except for your efficiency being absolutely trash when you're pushing like an amp through each phase. So yeah, it's basically sent efficiency to hell with that. We should go back on to the back of the card again. There's a little thingy right there. Right, that little dab right there, that's the LLC disable. That overrides the load line of the voltage controller. So if you actually solve the equation from the UP9511 datasheet for like 100 amps and some realistic values for DC resistance of the inductors, you're going to realize that that circuit has to be extremely low resistance, and it is. So when I was measuring around with the multimeter, which I'm so happy that I have the new multimeter, because it actually goes until milliohm range. So I'm sitting there going like, wait, what the hell? These two pins are basically shorted together. That can't possibly be right. These are meant to set LLC. But if you do the equation, it makes actual sense. So at that point, I was like, so originally I wanted actual LLC control, like the ability to tweak it up and down. Once I realized that those two pins are basically shorted together from like any normal perspective, like they're like there was like 0.07 ohms between them, something like that. So very low resistance between the two. Well, now there's 0.01 or 0.02, something like that. Because when you're measuring milliohms, like the multimeter isn't that accurate. Like it can do it, it's just like contact resistance becomes a massive issue. So yeah, but there's now less resistance there, so there's a lot less voltage droop under load. So the card's gone from drooping like 80 to 100 millivolts, depends how much voltage you were pushing, because more voltage, more current, more droop. But with that, it droops like 10 millivolts, which is great. So yeah, basically I killed the droop on the card with that little dodgy bit of that. That's not just solder, there's actually wires in there, because I was trying to bridge it with just solder and it just wasn't doing it. So yeah, that's a little wire that got jammed in there. Rest of the card, we have a bunch of Tantalum capacitors. These are all tantalums, so 470 microfarads, and these are from Panasonic. This is for memory. This is for V-core. These don't actually help. The V-core stuff, and actually even the big ones on the memory don't seem to help much. But you may notice I also have these little multi-layer ceramics bodged onto every single memory chip. So every single memory chip now has a little 47 microfarad multi-layer ceramic attached to it, and that actually helps quite a bit. Like that really helped the memory overclocking range on this card, which kind of surprised me. But I saw the same thing with the GTX 1070, so yeah, this does actually help. That's actually worth bothering with. All of this junk, not really. Like that didn't do much. These guys right behind the core. Okay, so this right here is obviously for measuring core voltage, and I've left this pad open here because I plan to put the, when I attach the K-type thermocouple, like I did on the HD7970, I'm going to put it right on top of that pad, because that pad is V-core, and so it should be a direct metal connection to the core, and so it should be relatively low thermal resistance, and should give me more accurate temperature readings than what I had before, where it was basically just kind of floating in Plastidip. But we'll see how that works out. But like that's the theory anyway, that I'm gonna, you know, attach it right there. Other than that, you can see we have a bunch more of those 47 microfarad caps, and then these are two 150s, and those are two 470s. These are aluminum polymers, both of these. These are these are really expensive 3 milliohm ESR Panasonics. They tend to be really, really awesome. The card just doesn't seem to care about them. Like literally everything I've done, it doesn't seem to make a difference, which is really, really annoying. But we'll see if on LN2 it clocks any good. Like, I don't know. It's hard to say because on ambient, the card really doesn't scale with voltage. I shoved all the way up to 1.2 volts into it, and it just doesn't make a difference. Like, I saw more difference from changing the switching frequency of the VRM than from trying to raise the core voltage. So, you know, that tells you something. So, yeah. Pretty much, no, that doesn't cover it. Oh, over here we have memory voltage control. That's the same, actually, like, because the memory voltage range, this is GDDR5X, so maximum memory voltage you really want is about 1.7 volts. So that's implemented exactly the same as what I did for the V-Core. So there's a 330 and a 680 ohm resistor limiting it towards minimum voltage and maximum voltage. This one, however, is actually implemented correctly because the way that, like, this switch is actually implemented to turn the mod on and off. So that's nice. That one's done properly, the other one isn't. The thing with the, what was it? Right, interesting thing about the memory circuit here is this doesn't actually have ref ADJ wired up. So normally, because NVIDIA uses a VID interface called PWM VID, where basically you have a PWM signal going from the GPU core over to the chip that produces the voltage, and I'm realizing that this camera isn't in position properly, but going over to the chip producing the voltage, that PWM signal is then converted to an analog voltage value, and then that gets shoved into the ref in ref VREF circuit, and yeah, that's how you control voltage. But because the memory voltage is static on this card, as in this card just sits at 1.35 volts all the time, at boot, at load, all the time, it just sits at 1.35, the resistor that normally connects the ref ADJ to the rest of ref in and VREF actually wasn't present there. So normally you have to remove a resistor and then you can start doing all of your soldering. This one I didn't have to do anything, which was like, that was really odd because I thought, like, I spent a lot of time just triple checking everything because it's like that resistor should be there. Where is it? Yeah. But it turns out it isn't there. So that's kind of that. What else is there? Right, more capacitors over there. Yeah, that pretty much covers it, I think. Basically, yeah. Yeah, that does actually cover it. We have one absolutely... Oops. Camera fell over. Particularly stable. So, let's just go back to the full view. So that's the card here, you know? I still need to plasti dip it. Well, other than that, it is fully functional. It runs. I had it running before I actually made this video. Yeah. So that's the 1080 Ti. I could have also done the PEX rail down here, but after reading there's a guide from TIN from EVGA about overclocking the 1080 Ti Kingpin Edition. And they don't mention anything about bothering with the PLL voltage, so if that guide doesn't mention the PLL voltage, I'm going to assume I don't need the PLL voltage, and not going to bother with it. Though I've also heard from other people that apparently it's really important, so I don't know, conflicting sources. I can always add it afterwards, that's a nice part with PlastiDip. And, yeah, that's pretty much it. Oh, and this here is basically because the part of the PCIe slot that's missing, there's also a presence, like a GPU detection pin missing. And I thought that pin was actually important, but apparently it isn't because the card runs without it. So that's why this is normally just shoved through the PCIe bracket over here. Because, yeah, I don't actually need that pin. Which I was really worried it wouldn't boot without it, so that's why this was there, so I could plug it, like, jam this into the PCIe slot so that it would detect the card. But I didn't have to worry about that, which is kind of neat. So, yeah, that's the Buildzoid Edition 1080 Ti right here. And the last thing that's left is just adding that thermocouple and then plasti dipping the whole thing. And I wanted to go over this before I did all of the plasti dipping just so you could actually see everything before it gets covered up in orange. And yes, I'm going to be doing the whole card orange. So it's going to be rough. Well, it's probably a bit paler than that. Like this splotch right here, it's going to be like that the whole card's going to look like that. So yeah, that's the plan right here, and I just figured I'd show you the card, because might want to see it before it's, you know, before you can't actually see anything on it. So, yeah, that's it. I don't really have a plan for the rest of the video. It'll be interesting to see where this maxes out. I'm hoping that it does over 2400, okay? Which, Like, it would be crazy if this thing did like 2500 or 2600, but you need like really good cards to do that. And I don't like this card is pretty garbage on ambient cooling. Like, it doesn't do even 2050 core. And I'm not sure if that's just me being trash at overclocking in videos, or if like I don't know what's up with that, but it just doesn't really go over 2037. Like, it doesn't do 2050. It doesn't really do 2037 either. Like, it'll sometimes blip to 2037, but trying to run it constant at 2037 doesn't really work. So, yeah. It will be interesting to see how this does on liquid nitrogen. So, yeah, now it's just, you know, dip it, and I'm going to be dipping it all the way to the VRM, because 1080 Ti's have a like, some 1080 Ti's don't have a cold bug, and then you can just run them as cold as you want. And in that scenario, I could very easily see the entire thing just frosting over, like, up to here. And then every time you run a workload, the VRM would defrost, and then it would refrost. And so I'm going to dip over that. I do actually have a plan for the VRM heatsink, because the VRM is just this big flat strip. I'm going to take the VRM heatsink off of the dead I had a 990FX Sabertooth board, which died on me. Basically, I still have the heatsink off of that, because if you have a GPU where you just have a straight line for your VRM, you can just smack that heatsink over it, and it'll cover it. So that's basically the plan for that. Smack a big heatsink on there, throw an LN2 pot on it, and yeah, see what it does. No load line, no, you know, high switching frequency option enable. I'm actually pretty happy with how this card worked out. It's a bit like, it does look a bit like a rainbow, and then of course you have all the wires for actually controlling it. So this is like the monitoring stuff, PEX, MEM, VCore. So all of the monitoring stuff's on there. This is the voltage controls, and yeah, whole card done. And I did consider adding an extra power connector, but then I was just like, nah, because nah. I don't think it'll sustain much more. Like, this can do like 240 easy. This can do like 240. Yeah, like 240 easy. This can do like 360 easy. So, yeah, really no problem with like, well, that's like 600 watts total, and you know what? I don't care. I really just don't care. If I melt the 8 pins, that'll be a first, because I've never had that happen yet, where I'd overload, like outright overload the connector to the point where it'd be a problem that much. So that's the end of the video, I guess. Thanks for watching. Like, share, subscribe. Leave a comment, questions, suggestions down in the video below. If you'd like to see me going through the actual datasheet for the UP9511 to actually set up all of the modifications I've done, there's a video about that. You're gonna have to find it. I might bother to put it in the description, I might not. So we'll see. And it's not so much bother as remember to. But yeah, there is a video covering the UP9511, and basically the rest of the card is the same kind of thing, because the only other one I did was VMEM. Yeah, I'm bad at outros. Right, there's one last thing I need to mention. If you'd like to support what I do here with actually hardcore overclocking, almost forgot to do my e-begging bit. Anyway, so if you'd like to support what I do here with actually hardcore overclocking, like senseless abuse of, you know, rescued GPUs, because it was dead, then I have a Patreon, a PayPal, and t-shirts you can buy. You can find a link to all of that down in the description below, and I don't know why I'm pointing at the desk. It doesn't make any sense. I should be like, I can't do the, there, description under the video. And yeah, there's everything. So this video is terrible. Goodbye. Where's the stop button? There it is.